Hello, everyone, and welcome to another exciting episode on machine learning. Today, we are diving into one of the most fundamental concepts in machine learning, gradient descent. Whether you are training a neural network or a simple regression model, gradient descent is the magic behind the scenes, optimizing your model. So, let's break it down. What is gradient descent? Imagine you are at the top of a hill and your goal is to find the lowest point. To do this, you take small step downhill, checking the slope at each point to decide which direction to go next. The process of gradually stepping down to find the lowest point is similar to gradient descent in machine learning. In machine learning, this hill is loss function, a mathematical expression that measures how far off your model's predictions are. Gradient descent is the algorithm that helps us minimize this loss function by iteratively updating the model's parameter. Types of gradient descent. Gradient descent comes in three main flavors, each suited for different situations. Batch gradient descent. In batch gradient descent, we calculate the gradient for entire dataset and update our parameters all at once. It's accurate but can be slow, especially with large dataset. Stochastic gradient descent. Here we update the parameters for each individual data point. It's faster but can be noisy, causing the optimization path to zigzag. Mini batch gradient descent. Finally, mini batch gradient descent combines the best of both worlds using small random subsets of data to compute updates. It's faster than batch and more stable than stochastic. Learning rate. Why it matters. The learning rate is like the size of each step you take downhill. A learning rate that's too high might overshoot the minimum, while a learning rate that's too low can make the process painfully slow. The key is finding a sweet spot, a rate that's just right for your problem. Here, what look like visually. See how the step size affects conversion speed and stability. Now, coding gradient descent. Now let's implement gradient descent in Python using simple linear regression. Don't worry if you're new to coding, follow along and I explain each step. Here we import NumPy library where we have taken random values. We made ourselves a new NumPy array with some general values from 1 to 5, and for our prediction we took 2, 4, 6, 8 and 10 numbers, and also we initialize the parameters, that is MNC, which is slope and intercept. By default we have taken 0 and learning rate is 0.01 and the epochs here is 1000. And we made gradient descent using for loop with the range of epochs. And first we need to find out the linear regression. So we applied in the y prediction variable the formula of linear regression, also finding the error, and then applying the gradient formula and on both of our slope, because it actually depends upon the parameters, and using that it also applying that gradient descent using the learning rate, and then finally printing out the optimized slope and optimized intercept, and finally we get the optimized values if we iteratively applying this formula. Next is challenges and advanced technique. While gradient descent is powerful, it's not without challenges. Sometimes it gets stuck in local minima or struggles with vanishing gradients. That's where advanced techniques like ADAM and RMS prop comes in. We'll cover them in future videos. So, gradient descent is truly the backbone of machine learning optimization, and I hope this video has made it easier to understand. Don't forget to try the code we implemented today and experiment with different data sets and learning rates. If you find this video helpful, give it a thumbs up, subscribe for more, and let me know in the comments what topic you like to see next. Until next time, happy learning.